Hello everybody, Jake Raby here, Flat 6 Innovations. I want to welcome you back to Vision here. Another great technical video we're going to do to help you understand and demystify the differences between the IMS solution and some other things. So it's not that often that somebody like me gets to think about a project, gets to invent something, gets to see it come to fruition, and doesn't have to deal with selling it anymore. But in my case, that's exactly where I am. At the same time, I want to take you along my path here as I developed and invented the IMS solution, help you understand some of the things that myself and Charles Navarro from LN Engineering faced as we did this, how we had to do it all in darkness, behind the scenes, so nobody would know what we were doing while we were getting the patents in place and protecting what we had came up with for our intellectual property. And I want to help you understand a lot of the hassles and the life-sucking things that happened during that time period. And then I want to help you understand about some other technologies that are confusingly similar and may actually be marketed to help confuse you and make you believe that they are like the IMS solution. Now, the reason why we call this the IMS solution is because truly that is what it is. It remains the only permanent fitment for the IMS bearing problem in M96 and M97 engines from 1997 through 2008. So the night that I had the thought that led to the invention of the IMS solution, which has subsequently led to the issuing of 3 U.S. patents, basically it had to be simple. And really, I made it just like all the Metzger engines that came before it. The flat 6, horizontally opposed Metzger engine, starting back in the first 911 called the 901. From that point on, the idea that I had in creating the IMS solution had the same theory. It would be a plain bearing, okay? A plain bearing is fed with lubrication that actually makes a surface of oil, a high pressure surface of oil, that is your wear component, okay? So this bushing, even though it would be considered a wear component, the oil between this bushing and the IMS solution flange is actually what carries the load. Okay, I'm going to help you understand this a little bit later on, but it works just like the camshaft bearings do in a 356, just like the lay shaft does in a 547 4-cam Carrera, just like the intermediate shaft or lay shaft works in that Metzger flat 6. It has a bushing, basically an insert in the crankcase, and it is fed with a pressure-fed delivery of oil from the engine's oil pump. That is where the load is actually carried on that film of oil, not really the surface of the bushing. So what is different about the factory M96 or M97 design? Well, basically, the single row bearing you see here, it has 11 wear components in its composition. The dual row bearing, it has 20 components in its composition. That is the amount of balls, races, cages, basically inner and outer race balls and cages that you see on the dual row as well as a single row. So anytime a developer can get rid of all these components and go with one single load-bearing surface, I think it's a good idea. Now, a lot of the installers that install the IMS solution, the certified installers that we've selected and trained and hold in very high regard as the certified installers of this product all across the country and even across the pond and even into Asia, have agreed with us that this is a very, very good design. Now, recently on an edition of Wheeler Dealers, there was a IMS solution installed. Of course, they didn't say it was an IMS solution. You could look at the box and see where they faded out the logo IMS solution, and you can't mistake my component from any copycats because nothing else has this particular design, but they called it brilliant. And I tend to believe that the idea of simplicity is always brilliant. Now, when you look at these bearings, this isn't really simple. From a manufacturing perspective, it was simple in a good way for the engine to be mass-produced, but that proved to cause problems later on because these particular ball bearings don't live a long life around hot engine oil and around the loads and all the things that happen inside the M96 engine. So I grew up cutting my teeth on air-cooled engines and moreover working on anything that I could that ran. Go-karts, lawnmowers, tractors, Porsches, Volkswagens, it didn't matter. If it ran, I wanted to make it run better. I'm still that way today. So when these engines started having IMS bearing problems, I started thinking that bearing has to go. That's when I came up with the idea that subsequently led us to the IMS Solution being a product that is well respected worldwide. Now, not everything that you do ends up being a success the first time. And quite honestly, we don't learn from our successes. We only learn from our failures. The things that we learn the most from are the things that suck the most amount of life out of us or suck the most amount of money out of our wallet. And the IMS Solution was one of those things. For over a decade of my life, I spent working on perfecting this so it could be brought to the market and ultimately into my engines. Now, here at Flat Six Innovations, the only thing we have to sell you is an engine. Okay? I want to make it very clear to you that we don't even install IMS Solutions anymore unless you need an engine built. The reason why, we are simply too busy. My idea is to have an engine factory. We do engine development. We build engines. We have one commodity to sell you, and that is the best Flat Six Innovations full complete engine that you can buy. Okay? So I want you to understand very clearly that no matter what IMS kit you decide to go with, it's not going to benefit me. What's going to benefit me is if you choose to do nothing or if you believe this is hype and the engine then fails because of an IMS bearing and then you come see me, okay? At that point in time, that's when my company gains business. I've been out of all this stuff for 9.5 years at this point now. So my job was done with the invention and the development. Carrying on into sales was not my thing. I'm not much of a salesperson. I'm all about technical things, okay? So ultimately, when I came up with the IMS Solution, the idea was to fit these to my engines. I had no intention of selling these to anybody. We had no intention of ever bringing this to market except in the composition of a complete engine. It was the actions of some others in this industry that kind of jumped on the coattails, robbed a lot of notoriety, said things that was being done that weren't true, that led to this product being brought to the market. That's all. That one thing is what led me to hand this over to LN Engineering to let them sell this to the masses, okay? So I'm a Marine. We don't like to be invaded. When invaded, we fight back. That's kind of what I did, okay? So basically, when we talk about the IMS Solution, this has gone through many different deviations and changes over the years. Since brought to market, it has not changed. I want to say that again. Since brought to market, the product has not changed. From a developmental perspective, during the invention process and proving all this, it was changed 7 major times, okay? And what you see here is IMS Solution number 1. Okay, this one was the first one, and most importantly, it's the first one that failed. It's here in the trophy case at Flat Six Innovations Research and Training Facility, where we do all our hands-on classes. You can come see this one day. So one of the biggest mistakes that we made here on numero uno was listening to a metallurgist, basically a structural engineer. It came to us from a materials perspective and said, you need to use a certain kind of bronze for the bushing. I didn't believe it, but I listened to him. 32 hours later, we had an in-operation failure. At the same time, we didn't even know that the engine had failed because we learned that there was a fail-safe built into the design that we never even expected and would allow the engine to continue running even after the bushing had started to seize onto the flange, okay? So if you look at this flange, it's a lot shorter than the one of the later version, okay? So we made that a little longer going throughout time. Like I said, we had 7 versions of this. I'm just trying to help you understand what it takes to bring something to market. So maybe you could put yourself in my shoes and probably not care so much for people that try to kind of ride on your coattails or copy what you do. There's nothing worse than a copycat because, of course, it is much easier to imitate than it is to originate. Okay, so now I want to help you understand how the IMS solution works. We talked about it having a bushing, we talked about oil, the flange, all that sort of thing. We do have an unboxing video that we did last year that goes over the components in the IMS Solution kit. You might want to look at that in some of your travels here on YouTube. But basically, I want to help you understand how this works now. So here we have the patented IMS Solution oil filter adapter, okay? The oil filter screws on here. This is a high quality filter, okay? Filter screws on here, okay? But what I want you to direct your attention to is the way this is designed. So you see how we have the oil going through the center here. We have oil holes all along this outside perimeter, if you will, okay? The way this is designed, oil comes into the filter from the outside, travels through the outside of the filter to the inside of the filter, where it is then filtered, obviously, as it passes from outside to inside. Then that just filtered oil goes back through the center of the IMS Solution adapter, okay? The LN Engineering spin-on oil filter adapter is a loose interpretation of this that does not include this particular fitting here. So as the oil comes through here, it is then routed into this particular fitting that travels through an oil hose that you see here, okay? These thread together like this. Of course, in the engine, it's a lot more complicated about where this goes. Then you have this oil hose that then goes down and collects onto or connects onto the IMS Solution flange, okay? There's another fitting there. Now, as that oil that is just filtered, I want to bring this to your attention. This is another difference we're going to go over after a while. This is just filtered oil. And I want to drive a point home that this particular oil is the closest location to the oil pump. So in this design, and the fact that we were able to patent this IMS Solution oil filter adapter and subsequently the LN Engineering spin-on oil filter adapter basically means this is the very first dynamic component in the engine that sees pressure-fed oil. Before the rod bearings, before the crankshaft, before anything else in the engine sees any oil film, the IMS Solution is getting oil immediately. This is critical as we try to compare the IMS Solution design to some other things that are confusingly similar. The two main things we fight with in trying to control the intermediate shaft are radial loads and longitudinal loads. The radial loads are those that are basically put on the IMS Solution bushing radially as it tries to spin and control the positioning of the intermediate shaft to make sure it runs true. The second one is the longitudinal forces. Basically, the forward and aft movement in and out of the intermediate shaft as it tries to move during acceleration and deceleration and things changing within the engine, okay? So basically, we have to control those two surfaces. So here, we see on the radial surface, we have one oil hole. This oil hole ties into this main oil hole, and that is what distributes oil into the IMS Solution bushing, which then has actually some distribution grooves that help to collect that oil and then provide the film of oil that's going to suspend, if you will, or basically hold away the intermediate shaft from that film of oil. So again, we're making sure the intermediate shaft rides on a film of oil between these two components. In operation, we should never have these two components touch each other. There should always be a uniform film of oil between these two components, okay? Then, here on the other end, we actually have another portion of this that has a stud that goes over the end of it that encapsulates it here, and that actually is what distributes oil to help control the longitudinal forces exhibited on the intermediate shaft from constantly up and down, deceleration, acceleration, that sort of thing. So the IMS solution helps to control both of these forces longitudinally and radially, okay? It's not just addressing the radial problem. It's addressing the longitudinal and the radial problem, and basically those are the only two forces that are going to exert anything on the intermediate shaft. So now I've helped you understand the radial and longitudinal loads, how the IMS solution roughly works. Of course, I can sit here and shoot a 3-hour video about this and spend 4 hours on it like I do on my classes. But basically, just filtered oil comes through the oil filter housing, comes through a hose, and feeds oil directly into the IMS solution flange, where that oil then provides the wear surface for the intermediate shaft. Let's just put it like that. The intermediate shaft is riding on a film of oil with this design. Now we have our original bearings here, the single and dual row. As you can see, those ball bearings are asked to do two things: provide radial support and longitudinal support. And that's what a ball bearing is somewhat good at. These particular ball bearings have proven not to be very good at that particular job in this application. We're not going to talk about those anymore. Okay. So now, what I want to bring your attention to is the fact that we have another technology out there, or a couple other technologies that have popped up, that also use an oil hose to grab oil from somewhere on the engine and then provide that to the intermediate shaft area. Okay? So basically what we have here is we have a kit that's available domestically here, and this has a fitting that goes on one of the engine's cam covers. Okay, there's an open port there where this actually goes, and it is designed to pull oil from the valve train area, the camshaft cover area. So with this particular design, the oil hose connects onto the intermediate shaft bearing flange, as you see here, and then the oil flow is directed through a small hole here, and it sprays onto the dynamic surface of either a factory single row or a factory dual row bearing, okay? Now, what is confusingly similar about this is they both use an oil hose, but that is the only thing that is similar between this design and my patented IMS solution. The only thing that's the same is the oil hose. I will say that again. Now, the big differences here is, one, with this particular bearing design, we are really of the thinking through marketing that oil volume and cooling and lubrication is the major problem with the factory bearing. When actually my development has been the factory bearing has a problem with controlling load forces, both radially and longitudinally. The load is what kills these bearings because, let's face it, a component that has twice as many pieces like you see here on the dual row bearing should require twice as much lubrication. That's kind of just common sense. Twice the wear components, twice the amount of lubrication necessary. Where the single row bearing should really use about 1/2 the amount of oil to keep it cool and to keep it lubricated, okay? So in that case, you would think that the Eisen versus Porsche class action lawsuit would say that the dual row bearing cars up till the mid-year 2000 would have the highest failure rates if they were talking about lubrication being the problem. Actually, the single row bearing had an 8% failure rate versus the 1%, or really less than 1% at the time as released in the fact finding of the Eisen versus Porsche class action suit. So in this case, one really has to wonder, based on those facts from that particular class action lawsuit, if lubrication really is the problem. Because if lubrication is the problem, and if really taking a dynamic stream of oil and forcing it on the back of a bearing was really going to be what solved the problem, well, shouldn't this particular bearing have the 8% and this one have the 1%? Wouldn't it be backwards? If the dual row bearing requires twice the amount of lubrication because it has twice as many components versus the single row, if lubrication is really a problem, wouldn't you want the one that has the most components to have the most amount of oil? Wouldn't that one fail the most? So these are other things that we think go into this where you don't really have a lubrication problem, you have a load problem. And that's what the aggravator is. Because, of course, let's face it, the dual row bearing has twice as much surface area to handle those radial and longitudinal forces versus the single row. And again, if lubrication was the problem, wouldn't we see the dual row bearings failing at a much greater rate than the single row? Yes, we would. That's certainly not happening. Okay, so now that we've substantiated kind of how that works, I also want to say that this technology you see here is designed to remove the seal from the bearing. That's a great idea because we know those seals will fail, and we know that's one of the things that leads to the factory bearings failing, is the fact the seal fails, it kind of gets in the way of the oil getting into the bearing, you end up having problems because the seal is there, okay? So I get it, yes, remove the seal. So basically, for this technology here to work, the seal must be removed. Otherwise, it's going to be absolutely worthless because the seal is going to stay in the way, okay? So the seal is removed, and then we are depending upon one stream of oil to then spray against the face of the factory bearing, okay? Now, the thing is, you still have the same problem bearing there. You still have the same ball bearing there. You still have the same 20 wear components here and the same 11 wear components here. Nothing has really changed with that, except for now we are taking oil from a valve train area via this fitting, bringing it through this hose, and then forcing it into the engine to spray oil onto a dynamic component, okay? So I just want to help you understand the differences between these. This does not change the style of the bearing. The only thing that changes the style of the bearing is using a plain bearing like my patented IMS solution. This doesn't change anything about the composition of ball bearings being used either in single or dual row form. You still have the same design there. Here, we are just assuming that lubrication is the problem, and we are force feeding oil from a valve train area of the engine that actually needs a lot of oil to keep your hydraulic lifters healthy, okay? And we're bringing that via a hose up to this flange and then forcing that spray onto the back of a factory-style bearing. That's literally all that's being done. So the purpose of today's RenVision technical video was just to help you understand that things that are confusingly similar couldn't be more different. The IMS solution uses a plain bearing. Every other technology out there uses either a ball bearing or a roller bearing. There are no comparisons. Thank you for viewing.